I'm the manager of construction services for PCL in our BC region. Been with PCL for about 17 years, 14 of which in the project management stream in the last 3.5 years, really consulting with our project teams on technology integration, and which has primarily been focused on BIM. And I'm the co-chair of the Data and Digitization think tank with Building Transformations.
Okay. So I'm Geraldine Rayner. I'm the managing principal of SummitBIM Consulting. We're an organization that actually works with the owners to help them define their requirements so that they actually get an end deliverable that's useful for them. So, where's my... Has it changed? We are changed. So Aaron and I are going to tell you the tale of two projects. Some of it is not real. We basically picked and choosed from other projects to bring it together to tell a story of the sort of good and the bad. So it isn't specific to a particular project. But we're going to speak to that project from two different perspectives, from the perspective of the owner and from the perspective of the DB, or the design build side. So if I'm on an island and I see a boat, I'm going to think, great, fantastic. I'm going to get off the island, I'm saved. On the other hand, if I'm in the boat and I see the land, I think, oh, fantastic, great, I'm going to get out of my boat. And the purpose of this really is to say, where you are in the continuum of capital planning, design, construction, or facilities management, your perspective changes, your data needs change. And you need to understand the end at the beginning. You have to understand the data needs of the owner at the end and the data needs that they have during the project to test and validate. So we're looking at these two projects. One, Project B, had fairly clear, specific, defined requirements for the owner in terms of BIM and the data specification. And the other, Project A, is really somewhat murky and undistinct, and that's creating its own set of problems for Aaron, and you're going to speak to that for us. So both owners at the beginning had this idea, BIM. Ooh, great, heard of this, I want some BIM. So owner B employed an outside consultant, which happened to be us. We came in, we worked with them to understand their data needs at the end, and we developed a data and geometry specification for them and a set of BIM requirements, which was duly included in the RFP, and the project was tendered and awarded. The other project, Project A, they didn't go through that process. They picked and chose bits and pieces from other projects and compiled them into a short BIM requirement within the RFP, and then they tendered it. So if we look at Project B, the design team and the construction team had a very clear definition of exactly what was required from them in terms of assets that were to be included in the model and data fields that were to be included in the model and the timeline associated with them, as well as the data and documents that was to be collected and collated during the construction phase. Project A, on the other hand, is setting off into design and into construction with no really clear definition of what's needed and what's not needed. And they're working hard to try and work out what it is and to define it. They've also got the data in a load of different locations. So they're extracting data from multiple different software sources, which is from the design models, from commissioning software, from fabrication models, from a sort of facility database. And then they're trying to pull it all together. They're exporting the information into Excel. They're going to manage it somewhat in Excel. Then they're going to export it to a cloud CMMS system. And from there, they're going to export it to the final client CMMS system. So it's far from a straight line. If I look at this in terms of sort of, the roles, risk, and the participation, in Project B, the owner has retained us to manage the data side of their requirements. What it is they want at the end, it's our responsibility to audit to make sure the information is there. It's our responsibility to collect and collate all that information in a common database, it's a cloud database, and then to move that through to their CMMS system. So the risk is managed by the client and the owner of the information. Project A, on the other hand, the DB team is responsible for managing that risk and for managing it all the way down. And as such, it's a much higher risk for the owner and for the DB team. This is, it was mentioned earlier, a document that we generate, which is a data and geometry specification. It basically works with the owner and says, as an owner, these are the assets I'm interested in. It's based around a classification system. On this particular project, it's Omniclass, Table 23, and Rooms, which is Table 13. They say, out of this list, these are the assets I'm interested in tracking from a facility maintenance and operations perspective. These are the data fields I'm interested in relative to the design phase. This is the timeline I want that information in the model at. These are the data fields I want during construction, and this is where I expect to have that information provided to me because I need to work out how to maintain and operate my building long before you hit handover. So Project B was defined. Project A, it was a combination of 3 different data and geometry specifications that were designed for different clients that were given to the DB team as, here's your starting point, you generate something for me. So, hand over to you.
Awesome, thanks Geraldine. So now you've had kind of a window into how the BIM contract language was written for these couple of projects. We take you through exactly how we dealt with it as contractors. So I would say the differences that Geraldine highlighted in the contract development really fell into 3 main categories. On Project A, we were provided a loose 3-page specification with a single paragraph outlining what the handover model should look like. On Project B, we received a 70-page specification outlining how the entire deliverable should be put together. Secondly, on Project A, we were provided, as Geraldine mentioned, with a DGS, but it was included as a reference document. We were really asked to develop our own DGS. In Project B, the DGS was provided to us as a contractual document. And then finally, on Project A, we were not provided or prescribed a delivery platform, and were instead asked to use an asset management tool that is, quote, compatible with the owner's CMMS. On Project B, we've had a very specified asset management platform that we were supposed to use to capture the data. So what did we do? On Project A, we took the loose contractual language and leveraged it to reduce the deliverable requirements, because that's what contractors do. Compared to the reference DGS, we reduced LOD from LOD 300 down to LOD 200. In practice, this turned out to not be incredibly relevant, really a tactic to minimize our risk, but we need to develop LOD 300, 350 in order to deliver our construction documents, and so we will be likely surpassing the LOD 300 requirement. But we did have delay the deliverables from 50% design development to 70 and 100% design development to buy ourselves some time. This, worked in buying us time and giving us some space to figure things out, but it added a lot of uncertainty and really jeopardized our relationship with the owner because they couldn't really see what we were actually doing or developing. And if this conference was 6 months ago, I'm not sure I'd be up here with Geraldine. If there was a problem, if there is a problem, and as part of our strategy, we may be too far down the line to go back and correct it, likely resulting in a lower quality deliverable. And sorry, let's cut off here. Then we really the biggest piece was we reduced the urgency for our project team. Because we didn't have an upcoming deadline, I was really the only person on the entire project team thinking about this deliverable requirement and how are we going to manage this risk. And really the last piece in terms of the overall reduction in requirements, we reduced some of those specific deliverable requirements. Specifically, we eliminated about 50% of the shop drawings being attached to the model. On Project B, however, we really didn't have too much in the way of choice. With a tightly written specification and contractually binding DGS, we had no choice but to follow the specifications in the RFP. So this means really the owners are really well set up to get everything they want on Project B. So the undefined delivery platform. So what did it mean? It meant a lot of doing this on Friday night. It was really hard to figure out exactly what we had to deliver, and so we spent a lot of time internally trying to figure that out, and lots of time with the owner trying to understand what exactly they were expecting and what they really wanted. Additionally, this really creates an unknown risk as a general contractor or a design builder. We don't know what we're supposed to be delivering, so it's something that other general contractors may end up just throwing money at if they haven't really done this before, inflating the capital cost for the project. And in hindsight, for us, the database selection has really turned out to be a very large risk, and future definitely would be allowing software costs for that. I will say there was one benefit to this. We had the freedom to really optimize the database for cost and best fit to our existing workflows. So there is potential that as this kind of delivery becomes the norm in the industry, there are efficiencies to be gained from this model. On Project B, we weren't defining the system, so we didn't have any risk around that data integration with the owner specified system. We simply submit our Revit models and Geraldine does the rest. We really don't have that cost and risk associated with this part of the deliverable. Kind of oversimplifying a little bit here, it's definitely involves some serious planning, and Geraldine's going to start to take us through that in the next section.
So I found it quite interesting in the scenarios and questions that were put up first thing this morning. The one thing that I didn't see on the lists was data. And really, BIM is a data-driven digital process. And if we don't have data and we don't have a strategy for how we're going to build that data or manage that data, then we've got some serious problems. So the project execution plan, which everybody is familiar with, they tend to think about it as something that's used by design and construction, but it's also an incredibly important piece of information for the owner, because the owner needs to understand where is the data residing that they need, because they don't want everything. They want specific pieces of data. So where do they go to get that piece of information? When is that piece of information going to be available to me? How have you built the data set so I can actually get in and use it? So that project execution plan is a key piece of information for the owner when it comes to managing anything downstream. So an issue which owners are pushing for more now is to actually get built into the design data set, the asset hierarchy. And for anybody who's not in the sort of maintenance and operation side of things, an asset hierarchy is probably not a term you're familiar with, but what it is what are the assets that are upstream of any particular piece of equipment and what's downstream? So if I need to service it and I turn it off, where do I turn it off and what have I impacted downstream and what are the consequences of that? There are a number of ways of handling this. You can do it by including it in the name so that every asset will include the parent before the name of the asset. You can do it by including a parameter that says my parent is and point it to that asset. But this is something that's now beginning to be asked of the design side of the industry. It's something they're not terribly used to doing, and it's something that they're pushing back on. But having this information from an owner's perspective so they can build the relationships they need into their CMMS systems is huge. Otherwise, they have to go in retrospectively and try and work it out. On Project A, there really was nothing written in a specification or in any of the documentation that required the DB team to do anything. So one of the biggest issues as well for an owner is, can I get to this piece of equipment that you've installed to actually maintain it? Very frequently, and I'm sure if there's anybody on the FM side here, there's a piece of equipment, it's overhead, and there's a bunch of pipes running beneath it so that you can never get to that piece of equipment. So the data and document specifications we write says these assets must have space associated with them for maintenance and operations or replacement, including if it's overhead, I need a vertical shaft to get up to it. And once those are included within the model data sets, then you can start doing virtual coordination that will allow you to maintain those zones and spaces for the owner. So, project.
So Geraldine's talked about why this is valuable to the owner. I'm going to talk about kind of what we get out of it as contractors. Really talking about specifically here the BIM execution plan. It really it forces us to really create a plan. And I'm not sure that anyone outside of Geraldine has actually read our BIM execution plan, but by being forced to build it, we really had to figure out the roadmap to get there. We built it collaboratively with our design and trade partners, really providing a transparent agreement between all parties. And we've been able to incorporate into the BIM execution plan into their contractual agreements. And that transparency really trickles over to the owner. Our BIM execution plan is their window into our plan for digital delivery. If that window is poorly built, it won't provide the transparency the owner needs. And I have to say this is really a huge part of the kind of rocky start we got off to on Project A in particular. So what are some of the key ingredients that I think need to be part of the BIM execution plan? Putting a project base point in real-world coordinates. It really sounds super simple, but it so often creates problems. I'm sure there's a few people out there nodding heads. Setting up real-world coordinates does take a little bit longer up front, but will stop making mistakes or stop us from making mistakes down the road. Software and collaboration exchange information, really develop that in workflow format, not in words. Show it in workflows. Level of detail as a specification. We've talked a lot about LOD already today. For me, this was a great way of translating the level of development requirements to a broader team. So writing a specification outlining that a pipe's greater than 2 inches will be modeled to the correct size and location means something to all the project stakeholders. I can share this with the rest of my project team, and they really understand what the actual deliverable is going to be. And finally, and most importantly, is defining the standardization of the data. So we really need alignment on where the key information is coming from, whether it's asset data, coordinates, or room information. We need to define its location and standardize how it's going to be reported. It's definitely going to be more on this in a bit. So these are, I want to talk a little bit of the lessons learned, and this comes from both projects. Repeating a little bit here, but workflows. I spent a lot of time trying to write out what we were going to do rather than define it in workflows. It was much more impactful once we kind of got into the workflow piece. Building a little bit on the real-world coordinates, shared levels and grids file, so it's a standalone file that gets copied and monitored by all the project stakeholders. It means that everyone's levels and grids are the same across all the models. We lock down so there aren't mistakes. And it ensures all the models are aligned all the time. Changes to any level or additional grid lines get uploaded to everybody's model all at once, and moving the model is, I wouldn't say easy, but much easier when you've got a single model that needs to be moved, not a whole group of models that are linked together. And then the biggest lesson learned is really setting that data standard early. With all things BIM, doing something early costs virtually nothing, but implementing a change partway through can really mean manual changes to thousands or tens of thousands of entries. Defining the data structure partway through on both of these projects has meant we're stuck with some aspects that we can't change and they aren't ideal. Data is the most important part of the digital handover, and figuring that out early is paramount to successful delivery.
So I need to talk nearer the mic, apparently. So data management. You can't really collect and collate all this information for an owner at the end to push into another piece of software unless you understand how that data has been managed, how it's been structured, how it's been organized, and whether or not you've actually audited it and checked it. So these are some of the things that you would be looking for when you're looking at data. One of the things is conformity and consistency. Is the information residing in the same data parameter, or has each consultant put it somewhere different and given the parameter a different name? And is it even in a different parameter within the same design consultancy firm? It makes a difference when you're actually trying to search, sort, and filter that data. It makes a huge difference. whether you're looking at one parameter or you're trying to manage 20 parameters. And if you're managing 20 parameters, where's your duplication? Have you got duplication? Haven't you got duplication? Is there information missing? What point in time is that information to be available in the data set so it can be checked and it can be audited? This is just a couple of examples, screenshots. The first is of a project where data's missing and the data isn't clear. The name, if I look at it, really doesn't tell me what the asset is. There's no underlying classification system, there's no omni-class name, there's no omni-class number. If I look at the second set of data, I've got all the information there. I can actually look at it and I can say, okay, this all aligns, this makes sense, this is obviously the correct information associated to the correct asset. You're always looking for 3 pieces of data to check that things are what they are. So if I've got something that tells me it's a pump, but my omni-class name and number tells me that it isn't, it's a fan, then that's a flag. Which one's right, which one's wrong? If 2 say it's a fan and 1 says it's a pump, the chances are it might be a fan. But if it's a 50-50, then you really don't know where to start your investigation. So the other piece that Aaron's sort of going to talk about shortly is basically this concept of structured data. When we significant impact. So we need to consider that structured data. One of the simplest ways of starting to generate that structured data is to use an underlying classification system. And I know Brittany mentioned this. Doesn't matter if it's uniformat, uniclass, or omniclass, but it should be one of them. And you need the title and you need the number. And then you don't need to go around changing the names of all your families because that underlying information is telling us what it is. What we would ask of anybody that participates in this is please don't put your company initials as the first portion of the name of any of your families, because when you're searching for something, you don't actually start getting any results till you get to the 4th, 5th, or 6th character. And that's really, put it at the end if you must, because that won't impact that ability. So project A, Aaron is really going to have to go through a lot of hurdles, hoops, and roundabout to get to where he needs to get to export the data in a format that is going to be acceptable for the CMMS system. Project B is being managed by us with our own external cloud database, FMI, so it's ours, we've done it, we've been retained to use it, so it's a straightforward process. We know where the data is and what we're doing. Aaron's going to have to go through some sort of a data mapping exercise where he's got to find where the assets he needs are residing, where are the data points he needs to put relative to that asset is, and then assemble it all together. This is the video. I hope it's going to run. Oh, there we go. So this is actually our FMI interface that we're using on the project B. We organize the data into reports, which is basically by asset type. That makes it easier. We can then assign those asset types to a specific subtrade. When the subtrade logs in, then it's a secure login, so we've got an audit trail straight away. We can see information that's come from the design side of the industry, which tells us what the asset is, and then you've got the information that, in this case, the client has specified as being required relative to that asset type. As Brittany mentioned, you want to control the data format. So when you put a date in this field, it does it for you because it needs to be in a consistent format when you're dealing with data. It then gives you the percentage of information uploaded. You know when you've done it, it's all tracked. The names are there, the data's there. You can see what's still outstanding and needs to be dealt with. And finally, when we get to the end, we'll upload a document. So it's very simple. You just go find your document, hit upload, and it's now associated either to the instance of the asset or all types of that asset, depending on the requirements. And then the I takes you to the 3D. So this is still linked to the 3D geometry that has come from those original models. So there's your asset. You've still got all the design information associated with it. You've still got all the construction information that's being provided, loaded with it. And there's your document is associated still with that instance of the asset. So all the information has been tied together. It's all collated. It's all coordinated. And it can be exported out into any format that the CMMS system wants to have it in. So Aaron's got a hurdle. So he's project A. He's got to go through his maze, which he still has to some extent, define to get across the bridge. Whereas project B, it's all been defined. It was considered the end at the beginning. The owner specified exactly what they want. They have controlled the process. They've managed the quality of the data. And they are responsible through hiring an external consultant to actually undertaking that data and document collection and moving it over. It also, because it's in this external environment, it's given the owner the opportunity to go in and look at all the data and to understand how to maintain and operate their building. They can develop preventative maintenance plans and understand what's going to happen when they move the data over. So, Aaron.
So thanks, Geraldine. So they're going to kind of get into the specifics of exactly how we are at least attempting to do this. So Geraldine kind of touched on this a little bit, but I'm going to get into a little bit more detail here. So this is a simple diagram, but here we're turning 6 different data fields into two project-specific data fields. This allows us to consistently look for that information in the same place when we're using models and information from different companies. In reality, with each company, they might have different model elements using different fields for that description and tag or whatever else we're looking for. So even with only 3 companies, we could be looking at 20-plus data fields that we need to kind of interrogate if we want to look for this information if we don't standardize that from the outset. So, what do we get out of this? What's the value in standardizing this data? So, in construction, when we set up this data standard for the entire project, we can use it to generate our quantity takeoffs. Thinking square footages of cladding or volume of 35 MPa concrete straight out of the model. We use it in clash detection, setting up our search sets to assign mechanical process pipe, clashes in mechanical process pipe differently than we would for, say, domestic pipe. And we can use it for communication, using the parameters to highlight 2-hour fire-rated walls in a facility to our construction teams out in the field so they can actually see where these, say we need to put fire dampers in all of these walls, those types of things. When we get into commissioning, I think this is somewhere both the owner and general contractor start to benefit. We're able to generate this asset data list, straight out of the model. That means we're getting a one-to-one asset from straight out of our design models. So there's no more going back and counting fan coils on 2D drawings to develop this asset list. And then we're setting things up so we're only collecting the data once. We're not transcribing it from the commissioning software over to the O&M manual, those types of things. And then, as owners, I think where you really benefit is you have this, as you bring this data into your CMMS and CPMS systems, you've got this data standard. You've future-proofed yourselves against data interrogation you didn't even know, questions you didn't even know you wanted to ask your data. It's now structured so you can actually ask those questions. So, the details, how are we doing it? We're setting up a bunch of unique identifiers. And we're doing that through type, mark, and mark. Those of you familiar with Revit know these are kind of out-of-the-box parameters. Using the out-of-the-box Revit parameters can create some real problems, some technical mumbo-jumbo there. I'm not going to get into the details, but what we've done is created project-specific type, mark, and mark parameters. So our we use a project type mark to identify the type of asset or type of equipment. Imagine I have 2 air handling units, 1 and 2, so they would have type marks AHU1 and AHU2. Using the project mark, I know it's a little confusing, but using project mark, we're indicating the number of instances of each of those types. So I might have 3 AHU1s and 2 AHU2s. So combined, type mark and mark create this unique identifier, in this case, AHU1-03. This type mark information is used to create our drawing tags. So on our project, we built out project mark to include a level and instance designation to further assist with the data management. So you can see I've got AHUB, 05 is referring to the level, and 001 or 002 is the specific instance. You can see on the left, we've built up our tagging information from the type, mark, and mark because each of these items is reported on instance level on the drawings and in the database. On the right, our light fixture is only reported at the type level. So by leaving the mark information blank, our identifier remains only the type mark. This will ensure that I only get a single entry of the light fixture in my database. So that I'm only reporting information about the type in this particular instance. So using this common type mark and mark information, we can build out the asset database using the best possible source for collecting the data. Project management software for shop drawings, the asset database software for the architectural information, and commissioning software for the meat of the turnover information. We then get to combine these into a single data set in the asset database using our standardized and unique identifiers. Additionally, by breaking up type and instance parameters, we can upload type information like shop drawings against an asset type, and an instance information like serial number against the unique identifier type mark plus mark. Now, it sounds like we may have this all figured out, but there's definitely still some work ahead. We'll get into some of the challenges and opportunities.
So there's definitely challenges and there's definitely opportunities. And Winston Churchill said that the pessimist sees the difficulty in every opportunity, but the optimist sees the opportunity in every difficulty. I personally am an optimist. I think there's huge opportunity, but there are definitely difficulties that we need to address and work out as an industry. I think CAN-BIM has renamed itself Building Transformations. This is an industry that needs to transform. And if we consider the impact of something like the iPhone has had on how we communicate, how we take pictures, how we listen to music, and the impact it's had on all those industries, this industry needs to go through a similar transformation. And how we did things in a paper-based process needs to be reconsidered. It needs to have some innovative thinking, and we need to accept that we're going to make mistakes, we're going to get it wrong, and we have to go back. So this has been mentioned several times today, and this is one of the things where I think we need to rethink, reconsider, and possibly go back. LOD originally came from the gaming industry. It was how close an object was to the lens of the viewer, the more triangles you needed to model, and the further back it was, the fewer the triangles you needed to model. And that concept was brought over into our industry, and there was an assumption that as geometry gets more complex, data gets more complex. But that's not a one-to-one relationship. An owner is happy with really relatively simple geometry, but wants very rich, complex data. And this sort of soup of letters, which is, the LOAs, LOGs, LOCs, LOXs, really isn't the best way forward, in my opinion, anyway. The other big challenge this industry has is this concept of the record model, the as-built model, or God forbid you should actually use the term digital twin. If you use digital twin to the design side of the industry, then they get terribly nervous. But I always think digital twin sounds great, but are you talking about an identical twin or are you talking about a fraternal twin? They're two very different things. And again, if you don't define what you want, who's to say what you're actually going to end up getting? So this concept really needs to be transferred from a model to a data set. What the owner is looking for is a data set that represents the built environment and contains the information that they need, whether it's specific to an asset or it's a piece of information relative to a finish or a room or the occupancy load of a room. That's information that is vital to the owner for facilities management purposes. So we need to consider how we're going to tackle this problem. Do you say, I want to take the design models, and I'm going to ask the designers to update their models during construction so that the assets are placed within a degree of accuracy that has been predefined? Are you going to say, no, I'm going to take the fabrication models? But if you take the fabrication models, where's the owner going to get their schematics from if they want their schematics? Where are their rooms going to come from? And if you go the concept of the digital twin, where's the data coming from? Which model is the basis of that digital twin? How much geometry do you need? What's the data definition?
So Geraldine's talked a little bit about kind of, say, higher level industry challenges. I'm going to get into some of the specific challenges that we're still trying to work out. Asset hierarchy. So Geraldine touched quite a bit on this. She talked a little bit about looking at the parents or the upstream asset and or the downstream asset. And so one of the pieces that's really challenging with this, if we're looking at the downstream side, some mechanical pieces of equipment might have hundreds of downstream assets. So we're focusing this effort on the parents or upstream assets so we can start to manage some of this complexity. On top of this, equipment like air handling units and fan coils can be connected to 6+ systems: chilled water supply, hot water supply, chilled water return, hot water return, supply air, return air. So this makes standardizing the parent data really challenging. Which system do we report as the upstream asset? And Geraldine really kind of hammered this point home, was the way different CMMS systems actually manage the data. So whether that's including parent information as part of the name of the asset, which starts to mess with the naming structure that I just went through, or if it's a separate parameter. So both Project A and Project B kind of have different strategies on how we're actually going to try and capture this information. So we're still in the, say, time will tell, and which is going to be more effective. And it's really also going to depend on the owner's CMMS. Connecting to the owner system. For Project A, again, Geraldine kind of highlighted this, but for Project A, we have a plan, but it's really creating a CSV export that we're then going to upload into the owner's CMMS. We don't really know what that configuration looks like, and I'm really anticipating that figuring out how to do this properly is going to be a pretty time-consuming process. We could look at procuring software that has a direct integration with the owner's CMMS, but that starts to create a data security risk for the owner, and something at this point they're not really interested in looking at. Thankfully on Project B, that's Geraldine's problem, so not something I have to worry about. The next piece, Geraldine kind of showed it a little bit in what it looks like in her system. On Project A, it's going to be a little bit more complex. So we've got to figure out how we're going to manage these attachments. Construction industry practice is to submit batches of submittals. So our entire industry, whether that's subcontractors, designers, general contractors, we're all used to seeing a batch of air handling units come through for approval. When we get batched like this, for the digital handover, we actually have to go through and split up the PDFs, and trying to change this workflow into a single shop drawing workflow has proved to be a really daunting task, and not something that our project teams are really interested in taking on. So there's definitely going to be some overhandling of these shop drawings as they flow through the process, and then we've got to come back and break them up. It's definitely a fundamental change from the paper process. So, now we've broken up these shop drawings, we actually need to associate them with the correct unique identifier, or type mark and mark for those paying attention earlier. So our strategy is to save the individual shop drawings with the file named with the type mark. Using that, we're hoping to be able to automate a bunch of the work of uploading the shop drawings against each of the probably thousands or tens, maybe even hundreds of thousands of assets that we've got to upload this information against. There is a side benefit here for us of actually going through this process, so we're really trying to set it up early, is we can actually start to connect these shop drawings back to the model. So someone out in the field can pull up the shop drawing, or the drywaller can pull up the shop drawing for the light fixture and see how big the opening he's got to leave in his drywall is. And it is something that we've been managed to do on one of our projects in Cornerbrook on the 2D side, and something that we're looking to do on both Project A and Project B. Lastly, owner-supplied equipment. So as owners, I think this is really a message to you that you need to allow time to integrate into our system, whether that's the shop drawing process or the data collection software. If you're not part of our system, your data is not going to be part of the digital handover. On one of our projects, there's a list of equipment that's being provided by the owner. They've essentially accepted that they're not going to be part of our process. It's too much for them to be, I guess they don't have the resources to integrate into that system, so they're essentially working in their own silo, going to hand over traditional O&M, and likely their FM personnel are going to then go have to integrate all the information back in manually, like Brittany was talking about post-handover. So last thing I kind of wanted to talk about are some of the key takeaways, and Geraldine's touched a little bit on this. We're really all learning together. I've done a ton of learning over the last year and a half or 2 years on this process, and it's been great working with Geraldine, but I think we have to approach this as a collective effort, and it's, if we'd approached this in an adversarial way, we could have really got bogged down in some of the contract language. And so, approaching it as an R&D and a little bit of a give and take has been really, really helpful. I think this has been hammered home enough, but the owners really need to specify what they want. If they're not specifying that, it becomes really hard for us as contractors to figure out what they want, and likely we're not going to be able to give that back to them. I think 2 pieces on this, the length here. The feedback loop on learning is really long, right? So some of these projects are 2 to 5 years long, means we're not really getting feedback if stuff that we're doing is great. So, kind of getting up here, communicating, sharing our war stories. And then I think for me personally, to the owners, you're going to be running this building for 80 years, likely, maybe longer, and thinking about this full life cycle is to set this up properly from the beginning. You're going to get that value for 80 plus years, so it's worthwhile investing in this. There's going to be some potential upfront capital cost as well as some resources on your side to do this, but it's going to be well worth it and have that payback. You wanted to add there? Okay. We're on to questions. Tom, Jerry? We lose Jerry. I can repeat your question, Tom.
I think all owners and clients are concerned about data and how they manage it. So if you're a smaller owner, then the output can be an integrated PDF where you can search by asset type, so it's structured as an index. You know what assets you have. You can select that asset and it'll give you more information. So if you've got 5 pumps, it'll tell you what the 5 pumps are. It'll tell you the room that those 5 pumps are located in, the asset ID of those 5 pumps, and you select one of those pumps and it'll take you down and give you more detail, and you select more detail and then you'll get the shop drawings or the warranty certificate. So if you're a small owner, you don't need to have a massive CMMS system to handle it. You can handle it in a document we call an FMIR, which is just a highly complex integrated PDF that's an output from the data that's being collected through the project. If you're a large owner and you're dealing with 30,000, 50,000, 100,000 assets, then yeah, you really want to have a process in place to help you capture it, because otherwise, as Brittany said, it's a very time-consuming manual process, And as humans, we make mistakes 3% of the time, even when we're paying attention. So you've got a built-in error. So.
Any other questions here from the audience? I might ask one more. No, go ahead.
So in ideal world, do we still need to attach the shop drawings to the model elements, or we can just get the information from the PDF documents as a parameters inside the model elements itself?
I'll take part of that. I'd say, in the ideal world that you're describing, I think that it makes sense what you're talking about, where essentially you're saying the shop drawing doesn't exist. That information lives in the, whether that's in the model or in the database for all of that information. I might challenge that a little bit, coming back to, I think, what Brittany was talking about in terms of building on complexity. We're starting to talk about a massive amount of data points that we're then having to make sure being input in there correctly, and that information does already exist, and so in the form of the shop drawing PDF. And so I'm going to start to speak about stuff I don't really know about, but I would imagine in an FM world, I'm not going to be needing that data on a day-to-day basis. So the extra step of having to open that PDF once a year, once every 6 months is maybe not that, not a huge onerous task. So I think it comes back to the data points that you really need to care about as an owner are the pieces that you want to make sure are actually real, I guess, say, smart data that you can actually search for versus maybe dumb data that would be in a PDF. So I think that there, in a panacea, yes, that makes sense, but practically speaking, I think you probably want to think about being one step at a time. Let's start simple, I guess, if that makes sense.
The only thing I would add to that is managing data costs money. So where is the value to the data you're collecting? And as long as the PDF that's provided is a searchable PDF and it's associated to the asset it relates to, as Aaron says, it's a 1-2 step. I've got my information. It's not, I have to go down to the basement and I've got to try and find the binder and I've got to go through the binder, and then I find that the piece of paper that I need in the binder somebody borrowed 3 years ago and it's not there any longer. So, as Aaron says, it's step by step, but
how far do you take it?
Yeah.
Anything else?
I do have a question about the database management platform that you talked about. I think it was FMI. My first question is that an internal proprietary software that was developed by Summit, or is that based on a different software? And then part 2 of my question is, what does the process look like to transfer the data from that database to the software that the owner is using internally?
So yes, it is proprietary. It's software we developed to handle and manage this process. It's sort of available to others to use if they want to undertake the data extraction organization and the upload. That's up to them. The format we have typically found with owners is they will give us an Excel spreadsheet, which is how they upload, and the organization of that Excel spreadsheet varies from owner to owner. Some organize it on rows, some organize it on columns, some organize it by a series of different tabs for the different asset types, and we basically export the data in whatever format they want in that Excel spreadsheet. That's been the most common way currently for providing the information for upload.
Tom, we have one more from the online audience, from Jose. And the question is, have you applied this element classification and data hierarchy only to building projects or also to infrastructure projects?
We've, personally speaking, only to buildings, but I don't know if, Geraldine, you've got more.
No, it's been primarily buildings, but picking up the civil that surrounds the buildings, but not bridges or roads.
I can maybe add a little bit of color there. I think a lot of what I was talking about was really Revit-based stuff, and we are running into a challenge, and it wasn't one that I highlighted, where things that are modeled in civil or civil 3D, how are we getting that asset information, or how are we building out our data structure that say aligns with what we're doing on the Revit side. So that's definitely a challenge, and so I really haven't dug into the Civil 3D side of it and how we would build that out in Civil 3D. I couldn't answer that part of the question.
Great, thank you. Tom, over to you.